Alright, so moving on from the microsolvers for a little bit, let's talk about something a lot more advanced, but something that I think is good to know sooner than later, and that's the idea of expansion. So our simulation currently, the idea is to expand. The idea is that it's blowing up. We're putting density in here, we're putting velocity, and the velocity is carrying the density along the way. The simulation is always trying to keep pressure in check. If it has a large movement of velocity going one way, it's going to kind of suck in behind it going the other way. Everything's trying to maintain some sense of equilibrium. Expansion kind of throws out the window a little bit. It kind of breaks the sim. When you have an explosion, everything explodes outward all at once. Quickly, it adds lots of velocity. It will spread the density around. But even outside of explosions, you have things like steam coming out of a train whistle or coming out of a pipe. It's expanding. The gas is expanding into the air. So we can do that in our simulations, and we can do it without even doing actual combustion. And the key is it's added into the simulation, much like density is added into the simulation. We're going to make another kind of fog volume field, but the trick is, to make it look good, is we want to make little bits of volume that are kind of like little nodules, little almost the way I think of them as little bombs all over the place that are going to expand at once and push out to make lots of little, expanding bubbles everywhere. Now, if we just use the density as we have it here, well, then it's all going to grow out in the same way. So what we want is we want to like seed it. We want to put little seeds all inside of it that will grow into a bomb of sorts. So let us isolate the density coming this way. So we're going to start from this. And remember, this is making a density and velocity field. So here's the velocity field from before. Just have it turned off for now. This delete is going to say, hey, delete the density field out of here. No, wait, delete everything but the density field. So now we have just the density. We come to the volume VOP. And the volume VOP is running instructions over every single voxel in here, one at a time. Well, not one at a time, actually, it does it in parallel, which is the nice thing here. So we can do lots of different voxels all at once. So the density per voxel is coming in here. The per everything data is coming in here. In particular, we're interested in the position of each voxel, because we're going to query this anti-alias noise that I just made. There's lots of noises here to choose from. Anti-alias noise is a pretty good one to go with. I like particular the simplex mode here. And we can see it if we just put it right here. Basically, we're just disregarding the incoming density now and just putting the output of the noise. And just like most noises, you can scale the frequency up and down. You can, move it through space. All those good things. If what else I'm going to do is increase the amplitude, and we are still interested in the initial density. We just want to modulate. We want to multiply it times the result of this, and that will be our output. So there you have it. So now, as we scrub through this, we've got this kind of chunky looking version of this. So these will be our little expanding areas, so to speak. So I'll make a null here. We'll point to it, and we'll call it divergence, because that's actually what this is called in simulation lingo. It's diverging from. The vectors can point away from each other. They're diverging basically from being a purely pressure-based solution. So we'll come back in here. Now the divergence is actually seeded much the same way that we seeded velocity and density in here. We're going to make another one of these. We're going to make another source volume, and much like the microsolvers up here, all attached by this merge, we can merge these two together like so. And just so we keep them straight, I'm going to call this one density, if I can figure out how to spell density, and then we're going to put this one here, the divergence. And this one has a little preset. It has a expand here. And the presets don't do a whole lot. It just turned off temperature velocity. We're only going to add that volume that we made. And in fact, before we forget, I'm just going to put it here. There it is. And also very important is this SOP to dot bindings. Now it's looking for a divergence volume. There isn't one. There's a density volume. So we want to use that instead. So there it is. Density will become, well, it'll add to the divergence field. And the final thing is we only really want to add it when it's adding velocity and density in the first place. We don't want to keep expanding while, after we add that initial burst. So I'm just going to say refer to that field and then maybe multiply it by 10. And let's see what 10 gets us. Here we go. Oh, actually we have our focus of our simulation up there. I got to move it back down here. Cool. So let's see what we get. There it goes. Still kind of looks like the way our simulation looked before. There might be a little bit of divergence going on. It's hard to tell. As usual, we can always just blow stuff out if we just want to make sure that it's working. Okay, there it goes. So clearly we have way too much. But you can kind of feel that ballooning, like bloosh explosion kind of look. I bet 100 is probably more or less what we want. Doing things in factors of 10, orders of magnitude is a good idea. You don't want to just like try 1, try 2, try 3. You might as well blow it out first to know that it's working, and then, work your way back from there. Cool. Boosh. Then as you start to get closer to it, then maybe do it maybe 2 times as much instead of 10 times as much. So there it goes. Definitely more of a poof now than it was before. And if you needed to remember what it looked like before, we can always, oops, still simulating. You can always disable that, run it again, and you'll see from before it was more of a stringier kind of thing. I mean, nothing inherently wrong with this, but if we wanted to do some sort of steam poof or some sort of, again, if we were going for flak cannon like we were saying earlier, like from an anti-aircraft gun, that sense of exploding, a rapidly expanding gas is what we get from this divergence business here. I still have it running into the wall here. We'll have to fix that. But boosh, now it really feels like a kind of a pyroclastic kind of thing going on there. And it still slows down. Everything else still takes over. We still have our dissipation. We still have our turbulence and whatnot. But yes, playing with divergence is critical to, again, smoke belching out of any place where it was confined, or there was a train, smokestack, or a factory or something. It goes from being confined to being out. It's expanding rapidly. You'll want to do some kind of divergence, expansion kind of business.